Humans recognize objects almost instantly, faces, animals, vehicles, and everyday objects, without conscious effort. Teaching machines to do the same required a revolutionary architecture known as the convolutional neural network. Although humans see images, computers see only numbers. Every picture is represented as millions of pixel values describing brightness and color. Instead of analyzing every pixel independently, CNNs use small filters called kernels. These filters slide across the image, detecting important visual patterns such as edges, corners, and textures. Different filters learn different visual features. Some specialize in edges, others detect textures, colors, or shapes. Together, these feature maps allow the network to build a rich understanding of the image. After convolution, activation functions preserve meaningful patterns while suppressing weak signals. Pooling layers then reduce the image size, keeping the most important features while reducing computational cost. As images move through deeper layers, the network gradually builds more sophisticated representations. Early layers detect simple patterns, while deeper layers recognize complete objects. After extracting visual features, the fully connected layer combines everything the network has learned and produces the final prediction. The verdict: cat, with 99.8% confidence. Let's recap. To a computer, an image is a grid of numbers. Small kernels slide across it and light up wherever their pattern appears, producing feature maps. Pooling shrinks those maps. Deeper layers combine simple features into complex ones, and a final layer turns it all into a prediction. Convolutional neural networks revolutionized computer vision. Today they help diagnose diseases, guide autonomous vehicles, inspect manufactured products, monitor crops, and analyze satellite imagery. Images are static, but language, speech, and time series data unfold one step at a time. In the next episode, we'll explore recurrent neural networks and discover how machines learn from sequences by remembering the past.